Hi everyone. So this is our last tricky topics video for chapter 2, and we're going to go over chromosome counting. This also includes DNA molecule counting. So let's get started. So we're going to compare them first, look at them individually, and then I'm going to draw out a little picture for you guys just to bring everything home. So chromosome counting, what you're going to do is count the number of centromeres. So looking at this picture right here, there's one centromere. This is one chromosome. DNA molecule, count the sticks. So in this picture right here, this is 2 DNA molecules because there's 2 sticks. So in each sister chromatid, there's 1 molecule of DNA, but when the sister chromatids are together, it's just still 1 chromosome. Okay, so I'm going to go ahead and go through the chromosome counting using humans as an example, and then we'll do the same thing with DNA molecules. So human chromosomes through the cell cycle. Feel free to pause for a second and write out what you think everything's going to be. We're going to go from G1 at the very beginning all the way down to telophase and cytokinesis. Since they happen at the same time, I have them listed together. All right, let's get started. So we know that human chromosomes have 46, or human cells have 46 chromosomes. So in G1, we have 46 chromosomes. And then we go to the S phase where we still have 46 chromosomes. We know in S, what we're doing is DNA duplication, which is the sister chromatids. And sister chromatids that are together share a centromere. There's still 1 centromere, it's still 1 chromosome. Then we'll go ahead and go into G2, 46 chromosomes. All we're doing in G2 is growing, making stuff for mitosis, so nothing's changing with our chromosomes. Prophase, 46 chromosomes. All we're doing is packing them up, but there's still 46. Metaphase, 46 chromosomes. All they are doing is that they're now in the middle, but there's still 46. So now we're going to look at anaphase, and this is where we're going to see our first change for chromosome counting. In anaphase, you have 92 chromosomes, so we doubled it. This is because what originally was 1 chromosome with 2 sister chromatids, in anaphase, they split apart. When they're apart, this is now, there's a centromere here, there's a centromere here. So now there's 2 chromosomes. Sister chromatids together, 1 chromosome. When they're split apart, now they're their own chromosome. So we have doubled the number of chromosomes. And in telophase cytokinesis, this is splitting back up into 2 cells, and they happen at the same time, which is why they're listed together here. So now in each cell, we have 46 chromosomes because we had 92. Each cell took half. So you'll notice the 2 important things for chromosome counting both happen at the very end. Everything stays the same until anaphase, we double. Telophase / cytokinesis, we halve. All right, I'm going to run through the DNA molecules, and then I'm going to talk about approaching these problems before I do my drawing, because a lot of times it can make sense when you hear it, but then whenever you have an actual problem in front of you, it can get a little more complicated. So DNA molecules, again, using human cells as an example. Feel free to pause again if you want to write everything out from G1 to telophase and cytokinesis. Feel free to do that to practice, and then press play again. So let's get started. G1, 46 molecules. So remember, a molecule is just a stick. And then S is going to be our first important phase for DNA molecules, because we went from this in G1 to this in S. We added on a sister chromatid. Each one is its own DNA molecule, it's its own stick. It's 1 chromosome, but 2 DNA molecules. So we doubled our DNA molecules pretty early compared to our chromosome counting. And once you double it, it just stays that same number until it'll halve later on. G2, we have 92 molecules. We're not doing anything with them. Prophase, we have 92. We packed them up, but we didn't do anything. Metaphase, we have 92. They went to the middle, but we didn't do anything. Anaphase, we have 92. Because in anaphase, we know we go from this to this. Well, you went from 2 DNA molecules that were attached together to 2 DNA molecules that aren't attached together. So it's still the same number of DNA molecules, it's just your chromosome number that doubles there. And telophase cytokinesis, we had 92 molecules. Each cell swallows up half, so now we're back down to 46. So our important points for DNA molecules. In S, we double. In telophase cytokinesis, we split in half. you should notice something in comparison with chromosome counting is that for both of them, telophase and cytokinesis splits it in half. The only difference is where it doubles. With DNA molecules, it doubles in S, and with chromosome counting, it doubles in anaphase. So how to approach these problems? First, notice if the problem is asking you to count DNA molecules or chromosomes. And then think about, so let's say it's asking you for DNA molecules, you should have in your head doubles in S, halves in telophase. Now we know those two things. So then see, what is the question asking you to identify? Let's say it's prophase. I want you to think, okay, where does prophase happen? Happens after S, so we've doubled already, but it happens before telophase and cytokinesis, so we haven't halved yet, which means that we're still doubled. Let's go back to the chromosomes example. So let's say that instead the question asked you about chromosomes, and we'll use prophase and it asked you about prophase. So first you see chromosomes and you say, okay, when does it double, when does it halve? I know it doubles in anaphase, and I know it halves in telophase cytokinesis. Okay, it's asking about prophase. When does prophase happen? Prophase happens before both of those. That means it hasn't doubled yet. That means we just have our regular number, 46. So I hope that helps a little bit with how to approach these problems. It can be tricky, but practice is really, really important here, and you can make up your own practice with this very easily. You can have a cell that has 5 chromosomes and then write out the numbers. And in a problem, honestly, if you had to just write out this entire little set quickly, you could. It'll take time, but hopefully it would mean that you got it right. So yeah, there's your chromosomes and DNA molecules. And now I'm just going to do a little drawing hitting those major points so that you can see it for the visual learners. Oops. Sorry, I clicked the wrong thing. Okay. So what I'm going to do is I'm going to talk about what it looks like in G1. We're going to look at S. We're going to look at metaphase. We're going to look at anaphase. And then we're going to look at telophase and cytokinesis. And we're going to look at the chromosomes and the DNA molecules for both. So, and I am not going to draw out 46 chromosomes, so we're going to keep it nice and simple and say that we have 2 chromosomes in G1. So here we have 2 chromosomes. Remember to count the centromeres. So there's 2 centromeres, so there's 2 chromosomes, and 2 DNA molecules because there's 2 sticks. We go to S phase and we know that we make sister chromatids. So count those centromeres again. We got 1 centromere, 2 centromere. So that's 2 chromosomes, but 1, 2, 3, 4 sticks. So that is 4 DNA molecules. So we said 2 chromosomes because there's still 2 centromeres, and 4 DNA molecules. Metaphase, we're going to line these guys up in the middle. So here we still have 2 chromosomes because there's 2 centromeres, and 4 DNA molecules because there's 4 sticks. Now let's go to anaphase. I'm going to go ahead and add some little spindle microtubules here. All right. So now we still have 4 sticks. So it's still 4 DNA molecules. But if we went to count chromosomes, now each of these has its own centromere. And we know that when we count chromosomes, we count centromeres. So there's 1, 2, 3, 4 centromeres. So there's 4 chromosomes. And then telophase cytokinesis, I forgot to draw another cell because we split into 2. And we're going to take, basically what happens, we are going to take anaphase in half and take the left half of the cell into the left cell right here, and the side of the cell into the right cell. So let's draw that. Okay, so we have 2 chromosomes from this side going into this cell, 2 chromosomes from this side going into this cell. So whenever you're counting, make sure you're doing it on a per cell basis. So we're just looking at, we'll say the left cell right now. So we have in each cell 2 chromosomes because there's 2 centromeres and 2, oh, I ran out of room, 2 DNA molecules because there's 2 sticks. So let's notice where the changes happened. Our first change was right here. We went in S, we doubled our DNA molecules, and then that stayed the same. In anaphase, our change happened in our chromosomes. We doubled our chromosomes, and telophase, we halved both of them. So as long as you can remember synthesis, DNA doubles. Anaphase, chromosomes double. Telophase, cytokinesis, it halves. And anything in between, especially for your DNA molecules, anything between synthesis and telophase cytokinesis is going to have the doubled amount, because once it doubles, it doesn't halve until the very end. So that means in prophase, you have that doubled amount. In metaphase, you have that doubled amount. In anaphase, you have that doubled amount, and so on. So once it doubles, it's going to stay doubled until it goes back to splitting in half.
I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what genetics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are currently enrolled as a Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need to know about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online through Navigate, or just drop in during our open business hours. For more information about our current services, please visit our website. Thank you.